Molecules that have separated positive and negative centers are called polar molecules. This separation of charges is confirmed in an electric field. When the electric field is turned on, polar molecules orient their negative charge centers toward the positive plate and their positive ends toward the negative plate. Let's compare a number of molecules to show how molecular geometry can be used to predict the polarity of the molecule. Click on one of the buttons to compare those molecules. Consider the Lewis structures of phosphorus pentafluoride, PF5, and sulfur tetrafluoride, SF4. In both structures, there are 5 VSEPR pairs of electrons around the central atom, meaning that the electron pair arrangement about the central atoms is trigonal bipyramidal. The molecular geometry of PF5 is trigonal bipyramidal, but because of the lone pair, the molecular geometry of SF4 is a distorted tetrahedron, or seesaw. In PF5, there is a shift in electron density from phosphorus to fluorine, because fluorine is more electronegative than phosphorus. To determine the polarity, we must sum together the individual bond moments. The bond moment pointing up is equal in magnitude and opposite in direction to the bond moment pointing down. These bond moments cancel. If we sum together 2 of the bond moments in the trigonal plane, the resultant moment is equal and opposite to the 3rd bond moment in the trigonal plane. These 2 moments cancel, and the molecule is nonpolar. The dipole moment is 0. In SF4, there is a shift in electron density from sulfur to fluorine because fluorine is more electronegative. Also, there is an increase in electron density in the vicinity of that lone pair. As in PF5, the bond moment pointing up is equal in magnitude and opposite in direction to the bond moment pointing down. These bond moments cancel. If we sum together the 2 bond moments in the trigonal plane, the resultant moment is opposite to, but smaller in magnitude than the moment due to the lone pair. The 2 moments do not cancel, and the molecule has a net dipole moment. SF4 is polar with a dipole moment of 0.63 debye units.